Welcome back to part 2 on this section for conics. We're going to look at parabolas first, and there are two different types of parabolas. There's a vertical axis parabola, which is the one you're probably most familiar with, but we're going to write it in a slightly different way. Normally, we would write it as kind of like a quadratic function, ax squared plus bx plus c, but in this case we're going to write it a different way. We're going to write it as x squared equals 4py. And notice that if you wanted to solve for y, it would be y equals x squared over 4p. But we're writing it a little differently, so it's easier to identify the vertex, the focus, and the directrix. So before, you're more familiar with a quadratic function, and now we're looking at it as strictly a parabola with certain features that we're looking for. We need to find the vertex, the focus, and the directrix. The directrix is always going to be on the other side of the max or min. And so the parabola opens upward if p is greater than 0 and downwards if p is less than 0. So here are some examples in these two pictures. You can see how one is opening upwards, one's opening downwards. The directrix is opposite that, and we can find the vertex, which in this case is 0, 0 for both of them. The other scenario is when the graph of the equation is y squared equals 4px. In this case, the parabola is opening sideways. To the right, if p is greater than 0, and to the left, if p is less than 0. And it's interesting to note that the way the parabola is opening is also the direction the little inequality for the p is pointing. I don't know if that will help any of you, but it is helpful possibly to someone, so there you go. And you can see how the directrix again is opposite the side the parabola is opening toward. So it's on the other side. It's almost like it's holding it back, kind of like a wall. We're going to use these pieces of information to graph these parabolas. Again, we have more information here. P is the distance from the vertex to the directrix, and the distance from the vertex to the focal point in the x direction for this one, since it's opening to the right on this parabola. And 2p right here is the distance for the focal diameter. Now that we've kind of gone over the basics, we can use the coordinates of the focus to estimate the width of a parabola when sketching the graph. The line segment that runs through the focus perpendicular to the axis with end points on the parabola is the focal diameter of the parabola. I think, again, this will make more sense once we start graphing. The focal diameter is the absolute value of 4p. So remember when we had the parabola just a second ago opening to the right? If you want to know the full focal diameter, 2p will give you half the diameter, and another 2p will give you the whole diameter. So the focal point is midway between the two sides of this parabola. So altogether, if you add 2p plus 2p, you get 4p. So let's find the equation of the parabola with a vertex at the origin and f, the focal point, is 0, 2. So I'm going to do a little bit of filling in the blanks here. First, I'm going to list the vertex at the origin. So there's the vertex. And then I know that the focal point is at 0, 2. 0 in the x direction, 2 in the y direction. So I'll label that as F, the focal point, and I know that the distance from the focal point to the vertex is 2. If you can understand how important the distance from the focus to the vertex is, then it's going to be easier to graph all these other pieces. Remember that P represents how far it is from both the vertex to the focus and also the vertex to the directrix. So P equals 2. And I'm just going to highlight that right here. That also means that my directrix is going to be on the other side. So there's my directrix, meaning the horizontal line opposite the parabola. Since the focus is directly above the vertex, I know that the parabola is doing something like this. But I don't know exactly what shape it has yet, but I can find it. Remember that the focal diameter is 4 times P. And it's in absolute values, which means the focal diameter for this particular example is 4 times 2, which is 8. And so now I can go from the focus out 4 in one direction to the right and 4 to the left. This will give me the 2 sides of my parabola, which is enough to graph this thing. And you can see how this now takes shape, and I can just fill in the rest here. The key features here that helped us figure out, or helped me figure out how to do this, was that my focus is always going to be wrapped around by the parabola. It's almost like it's encompassing the focus, which helps a lot. Also, the directrix is equidistant away from the vertex as the focus, so that was easy. And then we know that if the distance from the focus to the vertex is P, then 4 times P will give us the focal diameter, which is how spread out the parabola is. The last part of this is to write the equation for this parabola. The equation will be based off the focus and the vertex distance, which is the P equals 2. And my equation will have the form x squared equals 4py. So this is fairly straightforward. I just substitute p with 2, and I get x squared is equal to 8y.